Hello everyone, today we're going to answer question 8 from chapter 4, so let's start reading. A mass of 5 kilograms of saturated water vapor at 300 kilopascals is heated at constant pressure until the temperature reaches 200 degrees Celsius. Calculate the work done by the steam during this process. Okay, so let's write down the given information that we have. First of all, we know that the mass is 5 kilograms, okay? And the pressure, or pressure 1, is equal to pressure 2 is equal to P in general in this case, which is equal to 300 kilopascals, okay? So we knew this information here from the question statement because the question stated that the saturated water vapor is heated at constant pressure. So the pressure here is constant until the temperature reaches 200 degrees Celsius. So now we know that it's 200 degrees Celsius. Okay. Calculate the work done by the steam during this process. Okay. So now we have to remember an important thing, that the formal definition of work from process or from state 1 to state 2 is equal to the integration 1 to 2 of pressure times dV, okay, the volume. And since the pressure is a constant value, okay, we can take it out of the integration and integrate from 1 to 2 dV, okay? And when we do our integration, we end up with pressure multiplied by V2 minus V1, okay? And also remember that the volume is equal to mass times the specific volume, okay? So remember this. So now we can rewrite the final work equation that we have here as pressure multiplied by mass multiplied by specific volume 2 minus specific volume 1. Okay? So this is the equation that we are gonna use to find out the work. Notice that we have the pressure and we have the mass. All we need to find is the specific volume 2 and specific volume 1. And when we have water, the only way that we can obtain the value of specific volume 2 and 1 is from the tables, okay? So we go to the tables and notice now, in order to decide which table we should go and look for the information in, you have to look at the question carefully and read it. Notice that the first state or the initial state is saturated water vapor, okay? So since it's a saturated water vapor, we know that the specific volume 2 or specific volume 1, excuse me, is equal to the specific volume G, okay? When the water is in the saturated water vapor region, the X or the quality is equal to 1, okay? So the specific volume 1 is equal to the specific volume G, okay? So now we have to go to the tables at the saturated liquid region, find where we have 300 kilopascals and find our VG. Okay, so let's now switch to the tables. Okay, as you can see here, here is the tables, and let's scroll down, or yeah, scroll down a bit to find the 300 kilopascals. Here are the 300 kilopascals, as you can see, highlighted. Okay, and the value of Vg is also here highlighted. Also notice the value of the temperature stat, which is 133.52 degrees Celsius, and remember that our final temperature was 200 degrees. Okay, so since 200 degrees is greater than 133 degrees, we are going to search in the superheated water region for the other information, or for the final state information. But for now, we have the value of Vg, which is 0.60582. So let's switch back and write that down. Okay, so Vg is equal to 0.60 582. Okay, 582 meter cube per kilograms. Okay, so now we have this. Now we need to find out the specific volume 2. Okay, and specific volume 2, we have to go now to the superheated table. So let's switch to the tables here and go to the superheated tables. Okay, superheated water tables, and scroll down to 0.3 megapascals, which is equal to 300 kilopascals. Okay, here is the 0.3 megapascals, and look for the saturation temperature, or sorry, the temperature of 200 Celsius. And as you can see here, here is our specific volume 2, which is 0.71643. So 0.71643. Let's switch back to here in order to write that down. So V2 is 0.711643. Okay, 43 meter cubed per kilograms. And now all we have to do is just substitute the values that we found out in the formula above. So work from 1 to 2. Let me write that in a different color. Okay, so work from 1 to 2 is 300 kilopascals multiplied by 5 kilograms. V2, which is 0.71643 minus 0.60582. Okay, and this will equal to, let's go to the calculator and plug in the values. 300 times 5 times 0.71643, okay, minus 0.60582. Okay, and the answer that we get is almost 166 kilojoules. And again, we use kilojoules because we used kilopascals throughout this problem. Okay, and also notice that the work is positive, so we have an expansion. Thank you for watching and see you in the next time.